All right, good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of tutorials. Now, I'm just doing a recap, and basically, I'll also try to do a bit of integration. So far, we have done normal distribution. So, this is where we were using the z-score table. Hope you can remember that. Um, yeah, so for the probabilities, let me just put a highlighter there so that hopefully you can see properly. All right, yeah. So if Z is a normal distribution with mean 0 and standard deviation 1, find the probability of Z less than A, which is equals to that. Okay, and the first question asks you to find the probability of Z less than B. And the second question asks you to find the probability of Z greater than B. So the first thing that we should find is A here. All right, so that is probability of Z less than A. So remember what we said previously, we should always make sure that we have less than A there and that we have Z there. That is when we can use the z-score table. So this is giving us 0.3. Okay, so for this case of the question, we're looking for A. Okay, so remember previously we had our z-score table like that. This side we had Z values. This side we had what we were looking for. So now in this case it is the opposite. So we've been given this, the answer is here. So this is 0.3. So basically we should just look for numbers that will correspond to 0.3. That will be our value of A. Okay. So what numbers are going to correspond to 0.3? So let me just switch to the table. Hopefully I have the table here. All right, so here is the table. So remember, you're looking for probability of Z less than A, which is equal to 0.3. So remember, the 0.3 is the answer. So basically, you're looking for that 0.3 inside the table here. So we need to look for 0.3. So we have 0.2. This is 0.2, 0.2, 0.2, 0.2, 0.3. That's from here. So this is the lowest 0.3 that we can have. So we see that it actually corresponds to, okay, this is 0.22222. Okay. Corresponds to 0.5. So we say negatives. So A will be equals to negative 0.5, negative 0.5. And up there, what number is there? 0.0. So basically, probability of Z less than negative 0.5 will give you the answer 0.3. So that is how you approach that question. So we found our A as 0.5. All right, so our A here is 0.5. So our probability of Z less than negative 0.5 give us 0.3. So now when it comes here, remember, I don't know if you remember this, but we discussed how you can deal with this type of iteration. So you have probability of Z of A less than Z less than B. Okay, I presume this should be a small letter b considering what we have here. So this should be equal to 0.6. Okay, so now remember we can break this one down into two parts. That is a probability of Z less than the bigger one, which is B, minus probability of Z less than the small one, which is A, and this would be equal to 0.6. We know what probability of Z less than A is equal to. So probability of Z less than A equals to 0.3. So probability of Z less than B would be equal to, so we can transpose this side, so that is 0.6 plus probability of Z less than A, which would be equal to probability of Z less than B. So basically we're looking for A and B. So that is, this would be 0.6 plus 0.3. So we are looking for probability of Z less than B, that is equal to 0.9. Okay. So now again here, it's the same thing that we are from doing. So we look for B here. So what value of B, which is a Z value that can give us 0.9? Again, remember, or if there was a number here, B, then we would have to look for it on this part of the column. Then the answer that we get, we usually find it inside here. So now inside, it is opposite. So this 0.9 should be inside here. Now we need to find numbers that will correspond to that 0.9. So again, we need to go back to our table. We look for 0.9 inside the table. That will give us the value of B. All right, so this is our table, and I think you should find out if it is possible for you to bring your own table into the exam for questions such as this one, so that you use the table that you are familiar with. So yeah, so we now look for 0.9. So as you can see, that is 0.8888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888888áfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfáfá 1 corresponds to 2, and up there, let me check, up there it corresponds to 0.9. So basically, probability of Z less than, this side we start with this one, that is positive 1, 2, 1.2, then we just say 9. This will give us 0.9. Okay, so yeah, so and you're done. So Z, so our B here, that will give us 0.9 is found like that. Okay, so that is how you deal with that question. So that is 1.29 for our B there. So our B there is probability of Z less than 1.29. This would give us 0.9. So we have our A. So let me just scroll up here. So we have our A. Our A is equal to negative 0.5, and our B, or capital B, is equal to 1.29. Now these will be easy to find. So now you're asked to find probability of Z less than B. So assuming this was a typing error, it should be capital B. So so probability of Z less than B, so that is probability of Z. Let me just let me clear the board. Let me just clear out here. So we know what our B is and what our A is. So now for the probabilities, the probability of Z less than B here. So less than B, which is capital B, considering the typing error. So this will be equal to probability of Z less than 1.29. Okay, so we've already worked out that. So we can just go on the table. So we look for 1.29 on the table. and that will give us 0.9. Okay, so again, if you've forgotten how we check for that, if you are looking for 1.29, first of all, you look for the first two digits. So that is 1.2 is here, then under 9. So under 9, so we scroll all the way to under 9. So that is under 9. So that is the number that we're looking for, which is 0.9015. Okay, so that is where we're getting that. So yeah, so that is how you're supposed to work out this problem. Okay, so that is 0, 1 something. Then same applies for this. So you're looking for probability of Z greater than A. So remember what we said, the values on the table are only for Z less than, so you have to convert this to a less than, which becomes 1 minus probability of Z less than A. So you already know what A is. So this is, you're looking for 1 minus probability of Z less than, our A is negative 0.5. So now you go on ahead and look for 0.5 on the table. So that is 1 minus, so we look for Z less than negative 0.5 on the table. So it will be 0.3, which we previously looked for. So the negative 0.5 is here. So that will give us 0.3. So basically, that is how you work out these problems. So this will give us 0.3, which is what we already had here. So we could have just used this. So this is 1 minus 0.3, which will give you about 0.7. Okay. So that is how you are supposed to work these out. Then, yeah, so same applies here. You can do the same thing that we've done. Do the same thing that we've done here. So you're looking for probability. So here, first of all, you find the probability of Z. So if you can look at this one, we have greater than. So we have probability of Z greater than B equal to 0.45. So for this one, what you have to do is first make this one a less than. So it will be 1 minus probability of Z less than B equal to 0.45. Then you transpose this, so it becomes probability of Z less than B equal to 1 minus 0.45. I guess it will give you about 0.55. So probability of Z less than B. So what value does 0.55 correspond to? So that will help you find your B there. Okay, so yeah, then from there you can work out this one. Then for A is straightforward. What value of 0.7 gives you A there? So that is what you do. Then you can replace your A and B in there and find the probability of Z being in between there, which we've also discussed on how you can work that out. I hope you can remember all that. Then here, these are straightforward values. We have the values now. We're dealing with the values. Then okay. So these are straight out values. So you just find them directly on the Z-score table. Hope you can remember how to do that. You can work out the entire tutorial sheet on the Z-scores and you submit, and I'll be able to mark your work. Then for these variables X, remember we said you have to convert them to Z-scores for you to find their probabilities. So we have the mean there and the standard deviation there. So you say probability of, let's say for instance, this one that we have, which is X greater than 60.3. So to convert this to a Z-score, it will be probability of, we put a Z there, then we maintain the sign there, which is greater than, then we have our X minus the mean over the standard deviation. So this is the formula. Our x is this value that is here. Our mean is what we've been given here, and our standard deviation is there. Then we'll get an expression, and since this is greater than, we make it less than by subtracting from 1. Same applies here. Since this is greater than, or this one is less than. Okay, so this one is less than, it will be probability of z. So where there is x, we replace with z. Then we maintain the symbol, which is less than. Then we say x minus the mean over the standard deviation. Then we simplify that and we find that value on the z-score table. Then same applies for this. We were interpreting the information that was given here. So we need to convert these. First, we need to make statements into equation here. So less than 197. So that is probability of x. So these are in x. So that is x less than 197. Okay. So x less than 197. So you need to convert this into a z-score. You've been given the standard deviation and the mean. So you can do that easily. More than, so that is x more than 0.5. Then here x between, so that is probability of x being between 198.5 and 199.5. Okay, so you can work them out. Then a recap here, we talked about the marks. The marks of 500 candidates in the examination is normally distributed with mean of 45. So let me just erase that. So with mean marks of 45 and standard deviation of that. So we looked at how to do that. So given that the pass mark is 41, estimate the number of candidates who passed the exam. So we're looking for 41. So we're looking for x greater than 41. Okay, so we're looking for x greater than 41. So since the pass mark is 41, we're looking for x greater than 41. So now, since we're also including those that made the 40% pass mark, we are going to say this. We can say this is probability of. We can go a 0.5 degree lower, so that we include the 41. So we can say 41 minus 0.5, so that we also include the 41. So if we were excluding the 41, would have said plus 0.5. So this would be probability of z. So what is 41 minus 0? That is 0.5. So 41 minus 0.5, that will give us 40.5. So that is less than 40.5. Okay, so this will include the 41. So greater than 41 does not include the 41. So for us to include the 41, we should start at 40.5. So now so here we will say, we're going to say we convert this to a z-score. That will be probability of z. So we follow the sign that is here. So greater than, we have our x, which will be our this, minus the mean all over the standard deviation. Okay, the mean you've been given, and standard deviation you've been given. Now what you'll find here will be the probability of getting 41. So the final answer has to be multiplied by 500 to find the number of candidates. Okay, so let me just work out this one. And I think in the next lesson, or in part 2, I can work out the integration part. So here would say that is 40 probability of z greater than 40.5 minus the mean. So what was the mean score that was given? So the mean was 45 and the standard deviation was 20. So that is 45 minus 20. 45 divided by 20, sorry, not minus. So 40.5 minus 45, giving you negative 4.5 divided by 20. So we're looking for probability of Z greater than negative 0.225. Okay, so we have that. And now what we have to do is convert this to a less than, because our table only has values for less than. So we subtract from 1. So we say this is equals to 1 minus probability of Z less than negative 0.225. Okay, so we go to our table, we look for negative 0.225. All right, so we look for negative 0.2, then 2 will be here. So let me just check. 2 will be here, so that will be 0.22. Unfortunately, we cannot find 225, so we can round off. So we're looking for probability of Z less than negative 0.225. So we don't have that. So the number here is greater than or equal to 5. So we can round off. We can look for Z less than negative 0.23. So it will land us here. So this is the value that we have. So that is 0.4090. So here this will be minus. So this will be 1 minus 0.4090. Then here we can subtract. So that is 1 minus 0.4090. This will give you 0.591. Okay, so now what you have here is the probability for the number of students. You just, so for number of students, you multiply 0.591 times the total, which is 500. So times 500. So only about, so this is giving you 29 point, is it 295.5? So which is approximately 296. Okay, so we round off to the nearest whole number. So that is 296 got above 40, okay, or above 41. So that is the number of students that got above 49. Okay, so if 5% of the candidates obtained a distinction by scoring X, estimate the value of X. Okay, so 5%. So 5% obtained a distinction. So what is 5% of 500? So that is 5 over 100 times 500. Then we can know the number of students that that obtained 5%. So this there will be 25 students. 25 students obtained 5%. Okay, so now the question is asking us to determine the mark. Okay, the mark that was put for a distinction. So what mark was put for a distinction? So it's the same thing that we were doing. So that is probability of x marks, say greater than small letter x. This is would be equal to 25%, which is 0.05. So these are the X there is representing the number of students who got above the distinction. So X is the students, the small letter x is the number of students that got above the distinction. Okay, so what we do is first of all, we say, so actually we're looking at Z, since we have the area here. So we have the area here, so we say Z greater than that. So we change this to a less than. It will be 1 minus probability of Z less than X equal to 0.05. Then we transpose, this is probability of Z less than X equal to 1 minus 0.05. So 1 minus 0.05, that will be 95. So we're looking for what value of X will give us 0.95. Okay, so what value of X will give us 0.95? So again, we go to the table. So we do what we did in the previous question. Then what else? All right, so estimate the interquartile range. So it is a question of how do you find the interquartile range. So that is the upper quartile, which is there is the first quarter, 100 divided by 4. So that is the first quarter is 25%. So first quarter, so quarter 1 is at 25%. That is 1 over 4. And quarter 2 is at 75%. Okay, so you do the same procedure as you did here. So after you find the probability of being at 25%, then you also find the probability of being at 75%. You multiply to the number of students, then which is a 500. Then you subtract those quarters. Yeah, so that is how you work out this problem. So this is just a recap. I don't want to make it long. So that is a full recap on normal distribution, and that is what we did. So now we go to did we do much of matrices? We did matrices, complex numbers. Yeah, so I think on statistics, you have the following data. Okay, for the following data, marks obtained at Moche Statistics students, calculate the mean. So this data is not grouped. So remember, we learned how you can calculate the mean. So yeah, we can decide to group the data, or we can just write out calculate the mean. Okay, so the mean will be the sum of individual data. The median will be laying the data out, then finding the middle point. Okay, then for the quartiles, you need to calculate quartile 1, quartile 2, and quartile 3. Okay, quartile 2 is actually the median, so no need to calculate that. So you just calculate quartile 1 and quartile 2. The lower quartile, quartile 1, is 1/4 of nth. Okay, so 1/4 of the nth. So we count how many values we have here. So then we say 1/4 of nth. So that will give us the position of the quartile. So for instance, this is 3 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the data here is 30. So 1/4 of 30 1/4 of 30, that is 30 divided by 4. This will give us 7.5. So we look for 7.5. 1, 2, 3, 4, 5, 6, 7.5 will be in between here. So you should make sure that your data is arranged in ascending order. So that will be 7.5 position, 7.5 position, which is just approximately the 8th position, but you have to find the average. So what you do is you start searching 1, 2, 3, 4, 5, 6, 7. So 7.5 is somewhere in between the data there. You find the average that will give you the quartile 1. Quartile 2 is 3/4 of the nth. So in this case, it will be 3/4 of n, which is 30. So that will be 90 divided by 30. Divide by 4. So 90 divided by 4, which will give you 22.5 position. So you count the data to the 22.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, until you get to the 22.5 position. Then you find, since it's halfway, you find the average of the numbers sitting between 22.5. Remember, your data has to be in ascending order, and you're done. Okay. Then for the box plot. Okay. So for the box plot, there are two things that we should look at when, or let me say a few things. So for the box plot, we need to find, first of all, the lowest data in our data. So the lowest number in our data point. So if we check here, our data point, the lowest number here looks like 50. I saw 50 somewhere. So this is 52. There, 50, 50, 50, 50. All right, so that is 52. We also look for the highest number. So for the highest number, it should be 80. You have 86. Yeah, so it's 86. So you put them there. Then you find the quartiles. So this is quartile 1 there, and you put quartile 2 there. So you put the numbers of the quartile range. So for instance, if you found that 78 was quartile here, and so on and so forth, then these will be part of the ends of the box. Then the range of the box will be there. So they'll be like this. Okay. So the whiskers of the box will be from the lower end to the other upper end. Then the boundaries of the box will be governed by the quartiles. Then there'll be a line there showing the middle point, and the mean will be there. So the mean is either above the middle point or below the middle point. Okay, so that is the box and whiskers plot. Okay, so the mean you show by a sign. You find the mean. If it's there, you indicate there. This line corresponds to the median. You put it down there. Okay, so that is what you do. So here I'm giving you this task. So draw a stem and leaf plot. So you jump this part. I just want you to do this part. So this data is not grouped. So you asked to find the mean and the median, then the semi interquartile range. So you need to find quartile 1 and quartile 2, quartile 3, sorry. So that is the upper quartile and the lower quartile. So quartile 1 is 1/4 of nth. That is 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we say n plus 1. So for that is 20. So for data that is less than 30, we say n plus 1. So that is n plus 1. Okay, n plus 1, which is nth. Then quartile 2, quartile 3 will be equals to 1/4 of n plus 1. Then we find the position of the quartiles and we count to the data. Then we find the semi-interquartile range. So semi-interquartile range is equal to 1/2 of the interquartile range. So how you find the interquartile range? Interquartile range is equals to the upper quartile minus the lower quartile. Okay, so the values of the upper quartile minus the values of the lower quartile, you put it here, then you simplify that. So that will be it. Then now it comes to integration. Okay, so integration. So for integration, for these questions that we have linear values inside the brackets there, as you can see. So these questions will be approached the same way. So for questions that have a linear value inside here, meaning that the highest power of the value inside there is 1. Okay, then this is the process that you use to integrate. So for instance, let me write the general form here. You have integral of some number, let's say a here, then you have maybe bx plus whatever number is there, k raised to the power n, then you're integrating with respect to x. So how you integrate is as follows. So the answer will be, first of all, the numerator will have a, then we'll have the b, the x plus k there, then the power will be n plus 1, then again this power will be multiplied here, that is n plus 1, then you differentiate what is inside here. So that is what is inside here, we're going to call it bx, which is just b. Okay, so if it is linear, it will just be b, so it will be b right here. Okay, so that is how you integrate. Okay, so here we have this example. Let me use the example here. So you're integrating this. So first of all, we write, let me write the integral. We are integrating 5x minus 3 to the power 7 dx. So what we do is, first of all, we write whatever number that is in front of the integral here. So there is no number here, so we don't write anything. Then we open brackets, we write the equation inside here, which is, or the expression, which is 5x minus 3, then to the power n plus 1. So we say n plus 1, so in this case it will be 7 plus 1, divide by 7 plus 1 here, so it will be 7 plus 1, close brackets, open brackets. Then we write the coefficient of the number that is corresponding to x, so that is 5 here. Okay, so this will simplify to 5x minus 3 to the power 8 all over 8 times 5. So this would be 8 times 5. So that would be 40. So this will be 8 times 5, which is 40. So that is how you integrate this. So in this case where n is negative, so you say n will be negative 5 plus 1. Okay, and this only applies if n is greater than negative 1. So if n, for instance, it would be a different case if we had 2x minus 3 raised to the power negative 1. If n is negative 1, we cannot do this procedure. Okay, so n should not be equal to negative 1. Okay, so I'm going to give you this task to try them out and submit them, and I'll be waiting for the feedback. So basically, try these questions out, and I'll wait for the feedback. Have a good afternoon and evening.